The carcass has been dead for 4 days, it is bloated, it is crawling, and someone is about to eat it on purpose. Not by accident, not out of desperation so extreme that every other option had already failed. On purpose, with preference. With the same anticipation a chef feels pulling a slow braised shoulder out of an oven that's been running since yesterday morning. The people who ate this knew exactly what they were doing. They had waited for this. Everything you think you know about what ancient humans ate is about to shift. Not slightly. Structurally, the story starts in a university library in Ann Arbor, Michigan. The year is roughly 2010. An anthropologist named John Speth, professor at the University of Michigan, 4 decades into a career spent reconstructing prehistoric diets, is combing through accounts he calls the ethnohistorical record. These are the diaries, journals, field notes, and expedition logs written by European explorers, missionaries, traders, and government officials between roughly 1500 and 1900, documenting the lives of indigenous peoples before industrialization reshaped everything. Speth has been reading them for years, hunting through them for clues about what early humans actually ate before the textbooks simplified the story into a clean arc of hunting and cooking and fire. And what he keeps finding in account after account from every continent and every climate zone is the same thing. People eating rotten meat. On purpose. Happily, not as emergency food. Not as a last resort. As a staple. As a delicacy. As something deliberately prepared, carefully stored, and eagerly anticipated. One account stops him cold. It comes from Robert Peary's 1891 Arctic expedition. A Greenlandic hunter approaches Peary's ship carrying a seal he's brought as a gift. Excellent food, the hunter says, something to be proud of. The seal had been buried underground, possibly for 2 years. It is dripping. Maggots are moving through it visibly. The stench, according to Peary's wife, filled the air from a distance. Peary refuses to let it on the boat. The hunter is baffled, genuinely confused by the rejection. He tells Peary the more decayed the seal, the finer the eating. And he cannot understand why anyone would disagree. Speth reads that passage and asks a question almost nobody in his field had formally asked before. What if the hunter was right? The object enters here. Follow it. 1 caribou, northern tundra, late autumn. A Neanderthal hunting group will say roughly 60,000 years ago, somewhere in what is now northern Europe, brings it down after a chase. It weighs maybe 200 kilograms on the hoof. They butcher it where it falls, removing the internal organs first. The stomach contents, partially digested plant matter, rich in carbohydrates, are consumed immediately or very close to it. The tongue, the liver, the adrenal glands, which in wild game are among the only reliable sources of vitamin C in a landscape where no fruit is available. These go first. The lean meat gets set aside. This is the part the standard model of prehistoric diet gets almost completely wrong. For decades, the dominant assumption was that Neanderthals and early Homo sapiens were hypercarnivores, that elevated levels of nitrogen-15 in fossilized Neanderthal bones proved they were eating as much lean meat as lions and wolves, as much as 70% of their diet from muscle tissue. But here's the problem. A human being cannot safely eat that much lean meat. The liver simply cannot process the nitrogen load. Safe protein intake caps out somewhere between 25 and 35% of daily calories. Go above that consistently, and the condition has a name: rabbit starvation. Your stomach feels full. You are actually starving. The nitrogen in your blood climbs to toxic levels. It killed more than a few European explorers who ran out of other food in the Arctic and thought rabbit meat was a reasonable substitute. So Speth looked at those nitrogen numbers in Neanderthal fossils and asked, what else besides massive quantities of fresh lean meat could be pushing those isotope values that high? The answer came from the carcass. 4 days after the kill, flies have found the caribou. The maggots are already working. And here's the thing nobody thought to look at until Melanie Beasley, a biological anthropologist now at Purdue University, ran the numbers at the Forensic Anthropology Center at the University of Tennessee in Knoxville, a facility known informally as the Body Farm, where donated human remains are studied in open-air conditions to help forensic investigators. Beasley had been collecting nitrogen isotope data from decomposing tissue and the maggots feeding on it. The tissue nitrogen levels rose modestly as decomposition progressed, between negative 0.6 permol and 7.7 permol. Measurable, expected, the maggots were a different story entirely. Maggots, fly larvae feeding on that same decomposing tissue, showed nitrogen 15 values between 5.4 permol and 43. 2 permol. To put that number in context, Pleistocene herbivores, the prey animals Neanderthals were hunting, measured between roughly 0.9 and 11.2 permol. The maggots were registering up to nearly 4 times higher. Beasley and Speth published their findings in Science Advances in 2025. The conclusion was exact. The high nitrogen 15 signatures that had been used for 30 years to classify Neanderthals as hypercarnivores were almost certainly inflated by routine consumption of maggot-infested, decomposing meat. Not accidental contamination, routine consumption. If that just rewired something in your understanding of what ancient human behavior actually looked like, hit like. It genuinely determines how many people outside this channel ever hear this story. But here's where John Speth's work stops being a narrow technical dispute about isotope values and starts being something that upends the entire narrative of human prehistory. He published a systematic analysis in 2017 in the journal Paleoanthropology, cataloging hundreds of ethnohistorical accounts of putrid meat consumption in indigenous populations across the Arctic, subarctic, Africa, South Asia, and South America. The pattern he found was not the edge case of starving people making hard choices. It was the opposite. Across dozens of independent cultures on multiple continents with no contact with each other, the same behavior appeared: deliberate preservation of meat in conditions designed to advance decomposition, followed by enthusiastic consumption of the result. Fermented, aged, maggoted, liquefied, the Chuchi herders of the Russian Far East buried whole fish in early autumn, letting them freeze and thaw through winter, and dug up the resulting semi-liquid fish heads in spring as a prized food. The Inuit of Greenland pressed hundreds of small seabirds called little auks into a seal carcass, sewed it shut, sat a large stone on top to squeeze out air, and left the whole package for 3 to 18 months. The result, Kiviak, is still eaten today at celebrations, birthdays, weddings in Missouri. Native Americans in the late 1800s buried whole bison in winter and unearthed them in spring after months of underground ripening. A 1907 account from the Congo Basin describes British explorer Arnold Henry Savage Landor watching his companions haul a bloated, decomposing rodent the size of a small pig out of a river and eat it with visible satisfaction, while Landor himself was barely able to breathe from the smell. The Greenlander with the maggoted seal and Robert Peary's revulsion. The Inuit and their stinkhead fish. The Missouri bison buried for spring. The decomposing river rodent in the Congo. Different hemispheres. Different millennia. Same food logic. Speth's phrase for it is precise: they did not eat the smell. The smell is a modern signal, a cultural alarm. In an industrial world where food safety is managed by refrigeration, packaging, and expiration dates, the scent of decomposition has been recoded as danger. But that recoding is recent, very recent. The nausea you feel right now, reading about maggoted seal, that revulsion is not ancient. It is not hardwired into your genome. It is approximately 150 years old. Here's the reversal. Sit with it. The disgust is new. The rotten meat is old. And the rotten meat was nutritionally smarter than the fresh meat. Follow the caribou back, 4 days dead. The lean muscle tissue, the stuff that causes rabbit starvation in excess, has been partially broken down by bacterial action. The protein chains are loosening. The meat is easier to digest. The fat deposits, the internal organs, the bone marrow, things the group couldn't fully process immediately, are still intact, preserved in cold conditions, waiting. The maggots are now a secondary food source, fat-rich and nitrogen-dense. The entire carcass, 4 days later, is doing something that cooking does, pre-digesting food that would have otherwise required metabolic work the body couldn't fully spare. And here is the body evidence that Speth had been circling for years before the isotope data confirmed it. Human stomach acid. pH 1.5. That number comes from a 2015 study published in PLOS ONE by DAE. Beasley, Different Beasley, confusingly, and colleagues at North Carolina State University, who conducted the first systematic cross-species comparison of gastric pH across trophic groups. They compared obligate scavengers, facultative scavengers, generalist carnivores, omnivores, specialist carnivores, and herbivores. Obligate scavengers had the most acidic stomachs of any group, at a mean pH of 1.3. Facultative scavengers came in at 1.8. Herbivores sat at around 4.1 to 6.1. Humans measured 1.5. More acidic than generalist carnivores. More acidic than omnivores. Sitting comfortably in scavenger territory next to vultures and bald eagles. Not a carnivore stomach, a scavenger stomach. And the purpose of that extreme acidity is exactly what you'd expect. It kills the pathogens that flourish in decomposing meat. It is an ecological filter, the researchers concluded. A first-pass sterilization system that makes the intestine safe for whatever arrives from a carcass that's been dead for days. You were built for this food. That's the sentence John Speth had been working toward for 30 years of reading through accounts that every other researcher had quietly filed under curiosity or disgust and moved past. The modern Western revulsion toward decomposing meat is not a survival instinct. It is a cultural product of industrialization, germ theory, refrigeration, and the medicalization of food safety that began in earnest in the late 19th century. Before roughly 1900, no widespread cultural system anywhere on Earth treated all forms of aged or fermented animal food as inherently dangerous. Cheese is fermented milk protein. Salami is meat aged under specific bacterial conditions. Kimchi is vegetable matter deliberately put into controlled decomposition. The Icelandic delicacy carl is a Greenland shark whose flesh is literally toxic. When fresh, the fish stores urea and trimethylamine oxide throughout its body because it doesn't have kidneys in the conventional sense, and is only made safe to eat through 6 months of outdoor fermentation and drying, during which the ammonia heavy compounds off gas. It smells famously like industrial-grade cleaning product. It is eaten at celebrations. Gordon Ramsay spat it out on television. Anthony Bourdain called it the single worst thing he had ever put in his mouth. Icelandic people have been eating it since the Viking Age. The disgust is the anomaly, not the food. Subscribe if you want to follow where this goes, because next week we're tracking what happens to the gut microbiome when you remove all fermented and aged food from the diet, and the numbers from the last decade are not comfortable. Back to John Speth. Because his story doesn't end with the maggots, it ends with a reframe so significant that it quietly restructures what cooking was for. The dominant theory of cooking's origin, advanced most prominently by Harvard's Richard Wrangham, holds that fire was first applied to meat. That cooking meat provided the caloric density and protein efficiency needed to fuel brain expansion in the Homo lineage. The logic is compelling. Cooked meat is more digestible than raw. Cooking reduces parasitic load. Cooking increases caloric yield per gram. But Speth noticed something in the ethnohistorical record that cuts across that framework. Every group he documented eating putrid meat, without exception, was doing it to get fat, not protein. Fat wild game is extremely lean. Wild caribou, wild rabbit, wild reindeer, the muscle tissue has almost no marbling. Eating it raw or cooked in the quantities needed to sustain a northern hunting group through winter produces rabid starvation. What the decomposing carcass provided, alongside the maggots, were the things that didn't decompose. Fat deposits under the skin, bone marrow, internal organs, the brain. The rot made those accessible. Fermentation extended the window in which they could be retrieved from a kill that happened days or weeks ago, in conditions where transport was difficult and fire was not always available. If Speth is right, and his argument is contested sharply by researchers like Manuel Domínguez-Rodrigo at Rice University, who argues the scavenging model is too speculative to test. Then, cooking was not originally a meat technology. It was a plant technology. Fire unlocked the starches in tubers and grains. The fat and protein came from the carcass, already softened, already predigested, already crawling. Historians still argue about where the line is between intentional fermentation and tolerated decomposition in very ancient populations. The data is fragmentary. We will probably never know for certain at what point the first Homo ancestor looked at a 4-day-old kill and made a deliberate decision to wait rather than eat immediately. that moment is lost. But we know the body was ready for it long before the decision was made consciously. The scavenger stomach, the high acid filter, the gut microbiome of populations who grew up eating what the Congo River floated past. They didn't eat the smell, and neither, for most of human evolutionary history, did anyone else. The 4-day caribou, crawling in a cold northern European landscape 60,000 years ago. 400 little ox pressed into a sealskin in Greenland. A buried bison in Missouri thawing out in April. A bloated river rodent hauled onto a canoe in the Congo, and a group of people smacking their lips at what that European explorer couldn't even stand to look at. The same object. Decomposing meat. The same logic. Across every climate, every culture, every millennium of the time before refrigerators showed up and told us what food was supposed to smell like. The question isn't why ancient humans ate rotten meat on purpose. The question is when exactly we decided that was wrong, and whether the decision was ours to make or just something that happened to us along with everything else modernity changed without asking. Which stop on this journey surprised you most? The nitrogen numbers, the stomach acid, the Kiviak, or Speth's original library discovery? Drop it below.